For decades, astronomers had wondered if they would ever see it, a true visitor from beyond the solar system. The theoretical models were clear. Our galaxy, the Milky Way, is teeming with rogue objects, celestial nomads ejected from their home star systems by the gravitational slingshots of giant planets. They should be everywhere, floating through the vast, cold darkness between the stars. But until 2017, not a single one had ever been definitively detected. They were a ghost population, a prediction without a witness. Then, one thin, faint streak of light appeared in an image from a Hawaiian telescope, a streak that moved in a way no other celestial object ever had. It was a messenger from the void, Oumuamua. It was a first. It was a promise. But what it delivered was not an answer. It was a paradox. It was an object that should have behaved like a comet, but didn't. It should have been a normal cosmic rock, but wasn't. It was an alien artifact in the most profound sense of the word, and its very existence forced us to confront the deepest unknowns about what roams the darkness between the stars. It challenged everything we thought we knew, and in doing so, it left behind a profound mystery that still haunts astronomy to this day.
Stick around until the end of the video to uncover the full story of Oumuamua, from its fleeting discovery to the wild theories it inspired. And don't forget to like this video and subscribe to the channel for more amazing discoveries.
To understand the scale of Oumuamua's strangeness, you have to go back to the moment of its discovery. On October 19, 2017, a researcher named Robert V.E.X. was sifting through data from the Pan-STARRS-1 telescope on Maui, Hawaii. The telescope's job is to scan the night sky for anything that moves, from near-Earth asteroids to distant comets. It's a massive, systematic search, a kind of cosmic beat patrol. And that's when he spotted it, a tiny, faint, rapidly moving point of light. The object's motion was immediate cause for alarm. It was moving too fast, following a trajectory that was so extreme, so elongated, that it was clearly not gravitationally bound to our sun. The orbital eccentricity, a measure of how much an object's path deviates from a perfect circle, was a staggering 1.2. For context, a value of 1.0 means an object is on a parabolic escape trajectory, never to return. Oumuamua's number was even higher, a hyperbolic path that could only mean one thing. It had come from beyond our solar system and would leave just as quickly. Once that hyperbolic orbit was confirmed, the world's telescope swung into action. This was a once-in-a-lifetime chance, a fleeting opportunity to study a piece of another star system. But the clock was ticking. Oumuamua was already on its way out, accelerating away from the sun, and it was fading fast. Within a week, its brightness dropped by a factor of 10. Within a month, by 100. The window of observation slammed shut. What astronomers managed to glean in that short time was a list of properties so bizarre, so unprecedented that they defy easy explanation. The first and most striking feature was its shape. Oumuamua brightness varied by more than a factor of 10 over a period of about 8 hours. This isn't just a little wobble in brightness, this is a dramatic change. The only way to explain it is a highly elongated shape, like a cigar, or, as later models suggested, a pancake. Imagine a long, narrow asteroid tumbling end over end in space. When you're looking at it broadside, it's bright. When it tumbles to show you its thin edge, it's incredibly faint. It was an astonishing shape, unlike any known comet or asteroid in our solar system, which tend to be more spheroidal or lumpy. But it wasn't just rotating. The light curve indicated that Oumuamua was tumbling in a complex, chaotic way. This is a crucial detail. For an object that has spent billions of years traveling through interstellar space, you would expect any chaotic motion to have been damped down by internal friction. It should have settled into a nice, simple rotation around a single axis. The fact that it was still tumbling suggests a relatively recent energetic event set it into motion, perhaps a close encounter with a star, or maybe something else entirely. It was a cosmic tumbleweed, but one that defied the laws of cosmic thermodynamics.
Adding to the mystery, Oumuamua also had a reddish hue, a color often seen on the surfaces of some comets and asteroids. This color can be a result of cosmic rays or micrometeorites, a kind of space weathering that darkens the surface and gives it a reddish tinge. So far, so normal. But then came the anomaly that broke the mold.
Before we continue, I'd love to hear from you. What do you think about this discovery? Do you believe it changes the way we understand the universe? Or is it just another puzzle waiting to be solved? Share your thoughts in the comments. I'll be reading them.
As Oumuamua sped away from the sun, astronomers noticed something strange. It was accelerating. Not because of gravity. The acceleration was too strong for that. The only explanation was something we've seen on countless comets: non-gravitational acceleration. The sun's heat would be causing volatile ices on the surface to turn into gas, creating a kind of jet propulsion effect. This is standard comet behavior, but there was one massive, glaring problem. Comets leave a trail. They form a magnificent glowing coma and a dust tail like the ones you see on Halley's Comet. But Oumuamua had no coma, no dust, nothing. The Spitzer Space Telescope, one of the most sensitive instruments we have, looked for any sign of gas or dust and found none. It was a comet that behaved like a comet, but didn't look like one. It was a dark comet, an object that defied the most fundamental rule of its kind. This is the central paradox of Oumuamua. An object with the size and mass that should have given it a spectacular tail if it were made of water ice, produced nothing. If the non-gravitational acceleration was indeed due to outgassing, calculations showed it would have required the object to lose a huge amount of its mass. This fundamental contradiction, an object behaving like a rocket without the exhaust, is what has fueled the most intense scientific debate. If it wasn't water ice, what was it? This is where the natural hypotheses get truly creative. The first idea was that Oumuamua was a cosmic iceberg made of hydrogen. Hydrogen ice, or H2, is exceedingly volatile and would sublimate rapidly as it approached the sun. Critically, hydrogen gas is almost impossible to detect from Earth-based telescopes. This would explain the non-gravitational acceleration without a visible coma. The problem is that hydrogen ice is so fragile, It's highly unlikely to survive a journey through interstellar space for millions or billions of years. Cosmic radiation would have evaporated it long ago. Then came the nitrogen ice theory. Perhaps Oumuamua was a fragment of an exo-Pluto, a dwarf planet from another star system, that was chipped off in a collision. Its surface would be made of solid nitrogen, like Pluto. As it approached our sun, the nitrogen ice would sublimate, providing the thrust. This theory offers a beautiful explanation for Oumuamua's extreme shape. The heat from the sun would cause the outer layers of nitrogen ice to sublimate uniformly, like a bar of soap wearing down with use. It would slowly become flatter and flatter, transforming from a more typical shape into the incredible pancake we observed. This is a powerful idea because it provides a causal link between its composition, its behavior, and its shape. But again, it raises more questions. Have we ever seen a pure nitrogen object like this? How could a small fragment have survived this journey? Other ideas were even more exotic. What if it was a dust bunny? A highly porous, loosely bound agglomeration of dust. Such a structure would have an enormous surface area for its mass, so even the pressure of sunlight could cause it to accelerate. This would also explain the non-gravitational acceleration without outgassing. But a structure so fragile would have been torn apart by the sun's tidal forces. The recurring theme here is that every natural explanation for Oumuamua requires a celestial object of a type that has never been seen before. A hydrogen iceberg, a nitrogen iceberg, a cosmic dust bunny. While this doesn't make these theories wrong, it highlights just how truly anomalous Oumuamua is. It forces us to believe in something completely unprecedented to explain what we saw. And that's where the most controversial hypothesis enters the picture. What if Oumuamua was something designed?
Harvard astronomer Avi Loeb has championed the idea that Oumuamua could be an artificial object, specifically a solar sail. The idea is this: a solar sail is a massive, incredibly thin sheet designed to be propelled through space by the pressure of sunlight. A large, flat, thin object would have a huge surface area relative to its mass, giving it a powerful kick from solar radiation pressure. This would explain the non-gravitational acceleration without any gas or dust. It also provides a ready explanation for the extreme pancake-like shape inferred from its light curve. Furthermore, there is a powerful piece of empirical evidence that lends weight to this idea. In 2020, astronomers discovered another object that exhibited non-gravitational acceleration without a visible tail. It was dubbed 2020 SO. Upon further investigation, they realized it wasn't a comet at all. It was a discarded rocket booster from a NASA mission launched in 1966. Its light, flat shape was being pushed by sunlight just like a solar sail. This provides a tangible, real-world example of an artificial object behaving in a manner analogous to Oumuamua. The artificial hypothesis is also bolstered by Oumuamua's speed. It was moving at a velocity remarkably close to the average motion of stars in the local arm of the Milky Way, a kind of cosmic at-rest state. For a naturally ejected object, which would inherit the random motion of its parent star, this is statistically improbable. It's an unnervingly still approach. Could it have been deliberate? The scientific community, by and large, remains highly skeptical. The vast majority of astronomers argue that while natural explanations are challenging, they are not yet exhausted. To invoke extraterrestrial intelligence is seen by many as jumping to conclusions, a violation of Occam's razor, the principle that the simplest explanation is usually the best. The scientific process demands that all natural explanations be explored first, no matter how exotic they may seem. This is a crucial point. It's not a flaw in the scientific method. It's a built-in resistance to paradigm-shifting ideas. But what if in this case, the simple explanation is also the extraordinary one? Oumuamua's constellation of anomalies, its extreme shape, its tumbling, its lack of a tail, its near-stationary velocity relative to the galaxy, means that every single natural hypothesis has to invoke something unprecedented to work. The artificial hypothesis, on the other hand, can explain all of these things in one go. This is the great philosophical debate that Oumuamua has sparked. When does a series of anomalies become a new phenomenon in itself? This brings us to a crucial point in the Oumuamua story. In the years following its discovery, 2 more interstellar objects were detected, 2I Borisov and 3I Atlas. And here's the kicker. Both of them behaved exactly like comets. They formed comas. They had tails. They were a textbook example of what we expected interstellar visitors to look like. If Oumuamua was just the first example of a new common class of dark comets, the next ones we found should have been similar. The fact that they were not suggests that Oumuamua is truly exceptional. The importance of Oumuamua extends far beyond its strange properties. Its discovery alone changed astronomy forever. It was the first time we got a direct, tangible sample of material from another solar system. Before Oumuamua, our understanding of exoplanets was based on indirect observations, like watching a star wobble or BIM. But Oumuamua was a cosmic natural probe, a piece of another solar system delivered right to our doorstep. By studying it, we can get a glimpse of the chemistry and geology of worlds that are impossibly far away. We now know that these visitors are not rare. New estimates suggest that at any given time, there could be around 10,000 interstellar objects the size of Oumuamua inside Neptune's orbit. Our galaxy is not an empty vacuum. It is teeming with these galactic wanderers, the silent remnants of planetary formation from across the cosmos. This realization has set off a new space race. The upcoming Vera C. Rubin Observatory is being built with the explicit goal of detecting these objects. It will be able to scan the entire southern sky every few nights, a capability so powerful that it's expected to find dozens of new interstellar objects every single year. We're transitioning from accidental discovery to systematic study. And beyond that, new mission concepts are being developed to chase these objects down. The European Space Agency's Comet Interceptor mission, launching in 2029, will sit in space and wait for a suitable interstellar object to appear, then race to intercept it for a close-up flyby. Project Lyra is an even more ambitious concept, proposing the use of advanced solar sails or laser propulsion to catch up to future interlopers and study them in situ. Oumuamua came and went in a flash, but it left behind a profound legacy. It confirmed a theoretical prediction and gave birth to a new field of science. It revealed that the universe is far more dynamic and populated than we once thought. But most importantly, it presented a puzzle with no easy solution, forcing us to stretch our imaginations to the absolute limit. Was it a chunk of another planet? An object of a kind we've never seen before? Or was it something else entirely? The fact is, we still don't know. Oumuamua arrived and departed like a silent, ghost-like messenger, leaving us to wonder what it was, where it came from, and what other secrets are yet to arrive from the infinite darkness between the stars.